Hello dear students, today we will be going to discuss about database management system. This is the first introductory lecture for this subject. These are the given outline of today's lecture. First of all, we are going to discuss about purpose of database management system. Then we are going to discuss about various views, data models, types of languages in database management system. Then we are going to discuss about transaction management, storage management, database administrator, database users, and finally we are going to discuss about the overall structure of database. Before going into the details of database management system, first of all we should know what data is or what data are. Data are raw or isolated facts from which the required information is produced. Data are distinct piece of information, usually formatted in a special way. Say for example, employee ID / sale person ID, emp name, department, date of birth, qualification. The values for this are the datas. And for the salesperson, say customer name, customer account, address, city, phone number, etc. are data. Database is a collection of interrelated data. Obviously, if the data are not related, they cannot be stored. Of course, they can be stored in the database, but they won't have any meaning. So the data which are stored in a database are interrelated. And also the database management system contains a set of programs which are used to access those data. So in database management system, we have got two parts. One is database, the second one is management system. Database is the place where interrelated data are stored, whereas the management systems are the set of programs which are used to access those data. DBMS contain information about a particular enterprise. DBMS provides an environment that is both convenient and efficient to use. There are various applications which are based on database. For example, all the operations, all the transactions which happens in a banking system are database based. Similarly, in airlines also the database are used. In airlines, reservation, scheduling, allotment of seats are all based on database. In universities also you use database. For example, for registration of the students, for making tabulation and all, you use database. For sales and manufacturing production and human resource management also we use database. In short, we can say that database touches all aspects of our life. All the application that we use in everyday life, for example, Face, Google and everything, Facebook, Google, etc. uses database management system. Now, what is the purpose of database? In early days, database applications were built on the top of the file system. This means there was no separate database systems for storing data. Those file systems were used to store the essential data. But this approach has got many disadvantages. In this approach, we used to have some inbuilt directory. In those directories, these directories we call it as a system directories. In system directories, we used to have multiple number of directories. And in those multiple directories, we used to have our files. So these files are the actual places where we used to store those data. But this approach has got various problems. For example, this storing data in such an approach causes data redundancy and inconsistency. That is, a same information is stored in multiple places in a file, and also this multiple storage of information in various parts of the file causes inconsistency. Also, it arises multiple file formats. It also results in duplication of information in different files. Another problem with file-based approach is difficulty in accessing data. Since the file can be of different types, so different formats were used to store those data. So we need to write different program to access this data. And also there is a problem of non-data isolation. This means same information is stored in multiple files or in multiple locations in multiple formats. And also it causes the problem with data integrity. Data integrity refers to the overall accuracy, completeness, and reliability of data. It can be specified by the lack of variation of two instances or consecutive update of record, indicating that your information is error-free. The second problem with file system is the atomicity of updates. Failure may leave database in an inconsistent state with partial update carried out. Example, transfer of fund from one account to another should be either complete or not happen at all. Atomicity means multiple operation can be grouped into a single logical entity. Means if an operation or a set of operation is to be carried out, it should be carried out completely or it shouldn't be. Here an example is given. Now suppose a person A is transferring some amount to person B. So what are the steps? First, amount is deducted from A, and second, the amount is credited to B. Now, as per atomicity, these two operations should happen consecutively. If the step 1 happens or it is executed and step 2 is not executed, then there is a problem. This will rise inconsistent states, and it is due to the partial update which are being carried out. The second problem with the file system, or the second problem of using file system as a database, is that it doesn't allow concurrent access by multiple users. This causes problems especially when there are multiple number of users. In a typical system, all the users should be able to access a particular data or information concurrently. If this concurrent access is not provided by the system, then the performance is not up to the mark or satisfactory. And also, even if the file system provides concurrent access, the uncontrolled concurrent access may lead to inconsistent states. Now, for example, an example is given. If two persons reading a balance and updating it at the same time, then it may cause inconsistent state. So there must be a mechanism when two persons are reading, when multiple person or any person is reading the balance, during that time the updation process shouldn't be carried out. And beside this, there are some security problems. The files in a system or in a operating system or in a file system can be compromised easily. So all these problems can be solved easily if we use a latest database management system. The next topic is level of abstraction. Level of abstraction shows us how records are stored in the database. There are basically three types of abstractions. One is physical abstraction, logical abstraction, and view level abstraction. The physical level describes how a record is stored in the database. Normal users who are using the database are not concerned about the physical level abstraction. It is up to the database administrator how those data will be stored in the database. Then we have the logical level. It described the data stored in the database, and it also shows the relationship among those data. Here an example is given. Here we are storing some information, and we are assigning or we are giving a type to those data. And finally we have view level. The application program hides details of the data type. Views can hide information for security purposes. In a system, we can have multiple level of view. That is, for a given database, we can have multiple views depending upon our security concerns. This is the architecture of the database. The lowest level is the physical level, which deals with the architecture of the database. Then the second one is the logical view or logical level. It tells you what are the data and what are the relationship among them. And the third one is the view level, where the application user simply view a view depending upon their requirement. Instances are the collection of information stored in the database at a particular moment, whereas schemas are the overall design of the database. That is, the description of the database is called the database schema, which is specified during the database design and is not expected to change frequently. And also, the database schema can be partitioned according to level of abstractions. There are basically three views for the schema. The first one is the physical or internal schema. The second one is the conceptual or logical schema. Let me write it. Physical or internal schema. The second one is the conceptual or logical schema. The third one we call it as a external schema. The physical schema describes the physical storage structure of the database. The internal level or the physical level schema is concerned with the following activities. The first activity is the storage space allocation for data and storage. The second one is record description of storage with stored size for the data items. Number 3 is record placement. Number 4 is data compression and data encryption techniques. The second schema, which we call it as a conceptual or logical schema. Logical schema describes the structure of whole database for a community of users. The conceptual schema describes the entities, data types, relationships, user operations, and constraints, and also it hides the details of physical storage structure. And finally, we have the external schema, and this external schema describes the part of the database that a particular user group is interested in and hides the rest of the database from that user group. Instances means the actual content of the database at a particular point of time. Then we have the physical data independence. The physical data independence is the ability to modify the physical schema without changing the logical schema. The applications depend on the logical schema. In general, the interface between the various level and component should be well defined so that the changes in some part do not seriously influence other. So this means as we are given with three schemas, the change in the first schema shouldn't affect the second schema. Similarly, the change of second schema shouldn't affect the third schema. And this is called your physical data independence. It is the ability to modify the physical schema without changing the logical schema or external schema. Data models. Data models are the collection of concepts that can be used to describe the structure of the database. So it defines the structure of database. Here the structure of the database means data type, relationships, and the constraints that should hold on the data. This means there are various types of data models. The two popular models are ER model, which we call it as entity relationship model, and the relation model. Besides these two, we have other models also, such as object-oriented model, semi-structured data model, and also we have some older model such as the network model and hierarchical model. The first model, which is quite popular, is the entity relationship model, which are also called as ER model. The ER model is based on a perception of a real world that consists of a collection of basic objects called entities and their relationship among these objects. The overall logical structure of a database can be represented graphically by a ER diagram. There are various components in an ER diagram. The first one is the rectangular, which are the entity set. Here, the customer and the account are the entity sets. Then we have the diamonds. For example, this one. This diamond represents the relationship among those entity sets. Entities are the main items or components which interact with one another. And also we have got ellipses which represents attributes. These are attributes. These are the attributes of an entity called customer. Then also we have some lines. The lines are the links between attributes and entity sets, and also between entity sets and relationships. Beside this, we can have also double ellipse. For example, like this one. These are used to represent multi-valued attributes. And also we can have dashed ellipses, say like this. These are used to denote derived attributes. Then we can have double line also, like this one, like this one, It represents when there is a total participation of an entity in a relationship set. And also we can have double rectangle. Say for example this one. This is a double rectangle. This rectangle is used when there is a weak entity set. There are some advantages of entity relationship models. First one is it is straightforward rational representation. Having designed an ER diagram for a database application, the relational representation of the database model becomes relatively straightforward. The second advantage of ER model is it is easy to convert the ER model to other model. The third advantage of such type of model, that is ER model, is that graphical representation are very helpful for better understanding. But there are some disadvantages also. What is the disadvantage? There is no industry standard for notations. The second advantage is this ER model is popular for high level design of database. If for low level design of database, this model is not quite popular. So here again, these are the features of ER diagram. Then comes the relational models. The relational model uses a collection of tables to represent both data and the relationship among those data. This is a table, and this table is a collection of rows and columns. Each column has a unique name. These are the unique name. Each row in the table represent a collection of related data values. All the values in these rows are related. In a relational model, a row is called tuple and a column is called an attribute. These are the attributes, these are the tuples. There are advantages of such type of models. For example, it is very simple. The second one is there is structural independence. Means the relational data model does not depend on navigational data access system. Changes in the database structure do not affect the data access. The third advantage is it is easy to design, and also it is easy for implementation, maintenance and uses. The fourth advantage is it is very flexible and powerful query capability. But it has got some disadvantages also. The first disadvantage is there are hardware overheads. The relational data models need more powerful computing hardware and storage devices to perform relational database management system assigned tasks. Number 2, since it is very easy to design, the capability to design the database can lead to bad design. This is an example of simple relational database model. These are the tuples, these are the attributes. The language of the database is SQL. The database system provides two types of language. One is called as DDL, which is data definition language. The second one is DML. It is the data manipulation language. So, and also this data manipulation language can also be defined or categorized into two categories. One is as procedural DML, secondly as non-procedural DML. A data definition language is used to specify the database schema. This is an example of how data definition language is used to create a table. With the help of this statement, the DDL or the data definition language creates a table named account, which has got two attributes named as account number and balance. The account number is of character type, whereas the balance is of integer types. The data definition language compiler generates a set of tables stored in the data dictionary, and the data dictionary contains metadata. Metadata is nothing but data about data. So the DDL basically deals with database schema. Then comes your data manipulation language. It is a language for assessing and manipulating the data. And these are organized by appropriate data models. DML is also known as query languages. As we have already mentioned, there are two classes of DML. One is procedural, the second one is non-procedural. In procedural, user specifies what data is required and how to get those data. And in non-procedural, user specifies what data is required without specifying how to get those data. And obviously, SQL is the most widely used query language here. Example of procedural DML is PL/SQL, and the example of non-procedural is only SQL. Here, and also the data manipulation means retrieval of data from the database, deletion of the data from the database, insertion of data into the database, modification of data in the database. These are the manipulations. The next topic is the database users. Users are differentiated by the way they expect to interact with the system. The first one is application programmers, sophisticated users, specialized users, then naive users. The application program interact the system through DML calls, that is data manipulation language calls. Sophisticated users form requests in the database query language. Specialized user write specialized database application that do not fit into the traditional data processing framework. And the naive users invoke one of the permanent application program that have been written previously. Example, people using database over the web, bank tellers, clerical staffs are the naive users. And there is also an important person called database administrator. Database administrator is a person who has a central control of both the data and the program that accesses those data over the system. They coordinate all the activities of the database system. The database administrator has a good understanding of the interface, information, resource, and needs. There are various duties of database administrator which are as follows. The first one is schema definition, storage structure access method definition, schema physical organization modification, granting user authority to access database, specifying integrity constraints, acting as a liaison with users, monitoring the performance, and responding to the changes in requirements. These are the job profile of database administrator. Transaction management. Transaction is a collection of operations that perform a single logical function in a database application. A transaction in a database can be a collection of multiple number of operations. Say for example, A is transferring some amount to B, deducting the money from A's account, and also adding that amount to B's account can be called as a transaction. And this transaction includes two operations, that is deducting and crediting. Transaction management component ensures that the database remains in a consistent state despite system failures and transaction failures. Now in this case, if the transaction fails in between the operation, then it is the job of the transaction management component to complete the operation or to roll back the job done. In other words, the whole operation should be carried out or no operation should be carried out. And also, concurrency control manager controls the interaction among the concurrent transaction to ensure the consistency of the database. And also we have storage management. The storage manager is a program module that provides interface between low-level data storage stored in the database and the application programs and the queries submitted to the system. The store manager is responsible for the following tasks, that is interaction with the file manager, efficient storing, retrieving and updating of data. This is the overall structure of the database. Here we can see here the disk part is there. Then we have got the storage manager. Then we have got the query processor. Then we have got various types of users. In the disk storage, various strategies are there on how to store the data in the database. There are various managers in the storage managers for different purposes. For example, we have got buffer manager for the management of the buffer. We have got file manager for managing the files, etc. etc. And in the query processor, we have various applications for handling various aspects of query processing. And this whole diagram shows the overall structure of the database. In fact, we can say this figure gives us a view on how a user interacts with the disk storage of the database. This is a representation of application architecture. The application architecture can be of two types, that is 2-tier architecture and 3-tier architecture. In two-tier architecture, we have got a client part and we have got a server part. And in three-tier architecture, we have got in client part, we have got user and application client, and in the server part also we have got an application server and database server. That's why it is a three-tier, 1, 2 and 3.